Hi, my name is Aman Verma, and today I'm going to be talking about correlation and causation. Okay, so let's get started. There's a phrase that goes, correlation does not imply causation. What does correlation mean exactly? That's a fantastic question. Let me explain. A correlation is a statistical measurement of the relationship between two variables. Simple as it is. Possible correlations range from +1 to -1. There's a range. A zero correlation, meaning right in the middle, means that there is no relationship between the variables. A correlation of -1 means there is a perfect negative correlation, which means if one variable goes up, the other goes down. A correlation of +1, the other side, means there is a perfect positive correlation, which means that both variables move in the same direction together. Okay? Now let me tell you the simple definition of causation. That's the other part. Causation is when one event occurs, then another event occurs. So the occurrence of the first event is the cause of the second event. So without the first event happening, the second event doesn't happen. The second event has to have a root cause. A is before B at all times. So back to the phrase I was mentioning earlier. Correlation does not imply causation. The meaning behind this phrase, basically, it might be a little complex, but I'll break it down for you. It basically refers to the inability to arrive at a cause and effect relationship between two events or variables based on the correlation between them.
Hi, my name is Adam Roble, and today I'm going to be talking about causation versus correlation. Correlation is a statistical technique which tells us how strongly the pair of variables are linear related and change together. It does not tell us the why and how behind the relationship, but it just says the relationship exists. An example of correlation is between ice cream sales and sunglasses sold. As the sales of ice creams increase, so do sunglass sales. Causation takes it a step further than correlation. It says any change in the value of one variable will cause a change in the value of another variable, which means one variable makes the other happen. It is also referred to as cause and effect.
A correlation between variables, on the other hand, does not necessarily imply that a change in one variable causes a change in values of the others. Causation denotes that one event happens as a result of the occurrence of the other. Therefore, the two events have a causal link. Correlation is a test that looks for correlation between two variables. However, just because two variables move together does not mean we know if one caused the other to happen. This is why the phrase correlation does not imply causation is so widely used. Correlation and causality may appear to be synonyms. Recognizing their differences, on the other hand, can mean the differences between wasting time on low value features and making products that are your customers can't get enough of. Well, here's an example for correlation versus causation in product analysis. This picture is about a company launching a new version of a mobile app that makes bet that user attention for the product is linked in an app social behavior. Um a month after it's been released and announced, the new community features adoption sits at 20% of all users curious about whether communities impact retentions, and two equal sized cohorts are created with randomly selected users. One cohort only has users who join communities, and the other other only has users who did not join the communities. The analysis revealings are shocking. Users who joined at least one communities are being retained at a rate far greater than the average user. Nearly 90% of those who joined communities are still around on day one, compared to 50% of those who didn't. By day 7, you see 60% retention in the community joiners and about 18% retention for those who are not. This seems like a massive coup.